be considering Kirchoffs Voltage Law. We will first consider a small circuit. Suppose there is a resistor value R, and in the open terminals of resistor we are applying a potential difference V. Suppose 5 volts of potential difference is applied to a resistor R. Now, which are the devices which are used to apply potential difference? That is voltage. We can take the potential difference, that is voltage, from battery source. We can take it by power supply. Therefore, for a battery source or a power supply, there is a symbol, that is this. For positive terminal, long leg is there, and for negative terminal, small leg is there. So, suppose it is giving a voltage of 5 volts, therefore we will name it as this way, or a power supply. So, we will attach a battery to this resistance of 5 volt. Now, I will just analyze this circuit. I will come, suppose this point is I will start from this point. I want to go up. What is this? It is applying a what is this battery source doing? It is applying a potential difference. Potential difference. That is, as compared to this point is 5 volt more. If this point is of 0 volts, then this point is of 5 volt. If this point is of minus 5 volt, then this point is of 0 volt. This is of 3 volts, then this is of 8 volt. That it means. Now, going from X to Y, suppose this is Y. Going from X to Y, what is happening? There is rise in potential. As suppose considering this point at 0 volt, then this will be at 5 volt. What is happening? The potential is increasing. Therefore, there is a rise in potential. And by how much? 5 volts. That is, I will tell that V rise I have came at this point, Y. Now, from here to here, there is nothing element is there. Here also there will be 5 volt. Now, what is happening over here? If I want to go again down from Y to X indirectly, I am going. Instead of going from here to here, I want to go from here to here. I am going from Y to again X. What is happening? I am going from 5 volt to 0 volt. What is happening? There is a drop in potential. There is a loss. Therefore, I will say that I will just write this. When we go from high potential to lower potential, we call it as drop in potential. So I will just add my potential, that V rise. I was here and I went to Y. There was a rise in potential. Therefore, my potential rise increased by V rise. And then I am going from Y to 0. Suppose some amount of voltage is dropped. Then again, what is the potential over here? When I come, 0 volt is there. So I will sum all the potential equal to 0. Now we will see what is happening over here. How much amount of potential is rise? V rise is how much? It is rising by 5 volt. If I will write it to 5 volt plus. Now from 5 volt to make it 0, how much amount should I add? That is minus 5. And also practically we can see that going from 5 volt to 0 volt, how much negative voltage has to be applied? Minus 5. That is minus 5. Hence, what we can say, that rise in potential is plus 5 and drop in potential is minus 5 always. Or indirectly we can say, in other terms we can say that there is a loss in potential when we go through resistance, as it is consuming some energy. It is consuming 5 volt. Therefore, it is making our energy again equal to 0. Here we are giving energy. Voltage rise means gain in energy. That is, we are getting energy, and voltage drop means consumed, energy consumed. How much energy is consumed? As per the law of conservation of energy, voltage given, energy input is equal to energy output. No energy is stored. Here that is only happening. By battery we are giving energy, and by resistor we are consuming energy. Hence here voltage given is equal to voltage consumed. Voltage given is equal to voltage consumed. From where we are giving the voltage? By the battery. We are giving voltage by the battery. And where we are where our energy is getting consumed? In the resistor. That is, voltage given is equal to voltage consumed. Energy given is equal to energy consumed. Energy input is equal to energy output. That is, law of conservation of energy is followed over here. Hence, you can say that voltage rise plus voltage drop should be equal to 0, as they should be always equal and opposite. This should be always equal and opposite to follow the law as per the law of conservation of energy. That is, energy is never stored. It can be converted. Energy is never. It follows the law of conservation of energy. Now, if we I will now consider a circuit which contains two resistors. Considering a circuit of two resistors of same value. Suppose here again there is 5 volt, and here there is R and R. What will happen? Now instead of one consumption unit, there are two consumption units. Now again I will start from here. From here to here there is V rise. This is my V rise. From here to here there is V drop. As resistances consume energy, V drop 1. From here to here again there is again drop of energy, V drop 2. As for the law of conservation of energy, I will write V drop 1 plus V drop 2 is equal to 0. What is this V rise? How much? By how much we are rising? Amount voltage is rising by how much? That is 5 volt plus. Again it is dropped by how much? Now this is the question to ask. What is this? How much? By how much where our voltage has been dropped? Now earlier 5 volt was supplied to this R and entirely it was consumed. Now there are two same amount of resistors connected and 5 volt is applied across them. Then obviously by logic we can say that half amount of voltage is consumed by this R and half amount of voltage is consumed by this R. Therefore, what is the half of 5? 5 into half is 5 by 2, that is 2.5 volts will be consumed by this, and 2.5 volts will be consumed by this one. So there is a drop of V drop 1 is minus 2.5. Again V drop 2 is minus 2.5 is equal to 0. So I am denoting instead of denoting this value as minus, I will denote the drop as minus. So what I will do is V rise minus V drop is equal to 0. Can I write it this way? That V rise minus V drop 1, and this is V drop 2, V drop 1 plus V drop 2 is equal to 0. Now summation of this two, can I write it in this way? If there are more than one voltage sources, that is energy giving sources, then I will be writing that if there are two voltage sources over here, then I will be writing V rise 1 plus V rise 2 minus V drop 1 minus V drop 2 is equal to 0. Now I will be taking minus sign common, and V rise 1 plus V rise 2 minus V drop 1 plus V drop 2 is equal to 0. If there are as many as number of voltage sources, energy giving sources, then we will be writing it by plus, and energy consuming elements will be written, the voltage dropped by energy consuming elements will be written in negative, and I will be taking negative sign outside. And can I write this way? Summation of V rise minus summation of V drop is equal to 0, because all the net sum of all the energy given minus net sum of all the energy consumed is equal to 0, as our circuit is not storing anything, it is just consuming the given amount of energy. Therefore, this is our equation. Now, if I make this equation more compact, then how I will make that? I will just consider this on above, that is V rise minus summation of V drop is equal to 0. Can I just write one summation V is equal to 0, where positive voltage indicates the gained energy and voltage rise, and negative voltage indicates voltage drop? Can I write only this? Because since it is voltage, positive indicates gain and negative indicates drop. Then if I write in this way and say that sum of all the voltage just in a circuit or a closed loop is equal to 0, where positive sign indicates the voltage gain and the negative side indicates voltage drop, then this is called as our Kirchoffs Voltage Law. What does Kirchoffs Voltage Law says? It says that the net total sum of all the voltages in a closed loop is equal to 0. What is nothing but this? It is nothing but this. That's it. This is our Kirchoffs Voltage Law. Thank you. We'll consider this sum numerical on Kirchoffs Voltage Law. Consider this numerical on Kirchoffs Voltage Law. They have asked us to find the value of current in the given circuit. This is the circuit in which they have kept 2, 3 and 5 ohm resistors and connected to each other in series, and then they have connected a 10 volt battery source to it, voltage source to it. Now, how to find the current? We will apply the KVL here, that is Kirchoffs Voltage Law. How? I will just write the KVL. What does KVL say? That sum of all the voltages in a loop, in a closed loop, is equal to 0. I will be applying this concept over here. I will assume that a current I is flowing in the circuit. Always remember that electrons flow from positive electrode. Always remember the electrons flow from negative to positive. Negative to positive. And current flows from positive to negative. Always. Current flows from positive to negative, and electrons flow from negative to positive. Electrons flow from negative electrode to positive electrode, and current flows from positive electrode to negative electrode. Always. Now, from positive, my current is flowing. So, considering this, see, all the resistors are in series. So, the current flowing from all the resistors is same by itself. Now, I will start from this point. There is a rise in potential earlier. So, plus 10 volt, V rise, minus or plus, I don't know. Now I will see. See, from here, current is going here through resistor. What does resistor do? It is a consumption unit. It consumes energy. That is, it will create a voltage drop. So, how much amount of voltage drop will it create? I want this voltage drop. Suppose this is V2, this is V3, and this is my V5. Can I write it this way? Minus V2 minus V3 minus V5 is equal to 0. As all the three resistors are creating voltage drop. Always remember that resistors are consumption units. They consume energy and therefore they create voltage drop. And then this way. Now what is my V2? V2 is equal to, what is V by Ohm's law? Is equal to IR. I into 2 ohm into R. What is R? This is 2. What is my I don't know. It is I into 2. V2 is equal to I into 2. Similarly, V3 is equal to what? I into 3. What is my V5? I into 5. I will substitute the values of all V2, V3 and V5 over here. 10 minus I into 2 minus I into 3 minus I into 5 is equal to 0. 10 minus 10I is equal to 0. I is equal to 10 by 10. I is equal to 1 amperes. This is the value of current that is flowing in this circuit. What did I do exactly? I just applied this Kirchoffs voltage law. What it says, the sum of all the voltages in a closed loop is equal to 0. 10, that is voltage rise, minus voltage drop, minus voltage drop, minus voltage drop is equal to 0. That's it. That is only I have done. Always remember, in a battery, current flows from negative to positive. If it is going from negative to positive, what it is doing? It is gaining energy. And when current goes from positive to negative in a resistor, it loses its energy. Hence, in battery, there is a voltage gain, and here there is a voltage drop. From next time, we will just consider from this step. We will just start from this step. In exam also, you have to start from this step itself. Now consider this. In this circuit, they have asked what is the value of Vxy. That is the potential difference between Vx and Vy. This 2 points. There is a potential difference between 0.02 ohm resistor. And they have given current in each branch. You have to find from where we should start and what we should apply. First of all, when such a loop is given, always understand that they want to test your KVL concepts. Whenever they ask a current or voltage in a closed loop. No. How we will apply a KVL here? We know that in a KVL, we find mostly current, but in what way we apply KVL? By assuming current, by the direction of current. So we will assume one current. First step, assume current I. I will assume current, that is I, is flowing, and I will say that Vxy. What is the Vxy? Which is means what? Vx minus Vy. We are assuming that X is at higher potential and Y is at lower potential. Therefore, it is Vxy. Is equal to what? I into R. I, that is current flowing through that 2 ohm resistor, 0.02 ohm resistor. That is 0.02 I is my Vxy. Now, if I calculate I would be getting my Vxy. So, I will focus my energy on finding I. Now, from here I is going, now see, at junction Y, what is happening? 80 ampere current is also mixing with I. So net current going from this resistor is I plus 80. Now, while this current is coming from here, I will assume that current is going down from this branch. Now, what is happening? That some amount of current is going, 60 amperes is going from here. That is, the current going from here is I plus 80 minus 60, that is I plus 20. Now I will assume two currents are going inside, something should come outside, therefore I will assume electron current as this here. 110 plus I plus 20, what is that? I plus 130. After this, out of I plus 130, 120 is going this way. I will assume that some current is going in this way. So the current through this branch will be I plus 130 minus 120, that is I plus 10. Now I plus 10 is coming from here and 20 is coming from here. So current going here is 30 as I plus 10 plus 20. So I know now, assuming current I, in terms of I at least, I know the current in all the branches of my closed loop. Now I will apply my KVL. Always before applying KVL you should know the current in all the branches, at least in form of variables. Let it be. We'll start with point X and we will again come to the point X. Applying KVL. Now starting from X, what does resistor do? It creates drop, voltage drop. So and that voltage is denoted by negative voltage. I will write minus. We'll start from here as it will be a lengthy equation. I, what will be that voltage? I into 0.02. Again current is going through resistor, then what is this? Minus I plus 80 current through that resistor into 0.02. Again current is going through the resistor, therefore I plus 20 into 0.01 minus I plus 130 into 0.03, again minus I plus 10 into 0.01, again here minus I plus 30 into 0.01, and what is the sum of all the voltages in a closed loop? That is equal to 0. If I multiply the whole equation by minus sign, then everything will be on both sides, then everything will be plus. Now see, I'll just rearrange the terms with I just simply write it in this way: 0.02 I plus 0.02 I plus 0.02 into 80 plus this plus that term, that is plus 0.01 into I plus 0.01 into 20 plus 0.03 into I plus 0.03 into 130 plus 0.01 into I plus 0.01 into 10 plus 0.01 into I plus 0.01 into 30 is equal to 0. I'll just simplify it. I will take all the terms of I on one side, that is 0.02 I plus 0.02 I. Which are the terms? I will just underline first. These are the 6 terms, so I will just underline it. Plus 0.01 I plus 0.03 I plus 0.01 plus 0.01. 0.01 plus 0.01 I, and then I just circle the terms which are not having any I. There are again 6 terms, sorry 5 terms are there. 80 into 0.02, that is 1.6. 1.6 plus, and this is 0.2 plus 3, 39, 0.39 3.9 again, then 0.1 plus 0.3 is equal to 0. I'll just rub this. I'll be rubbing this upper side, and then I'll see 0.02 plus 0.02 plus 0.01, that is 0.05, 0.08, 0.09, and 0.09 plus 0.01, that is 0.10. That is, this is 0.10 I plus, what is this values again, 1.6 plus 0.2, 1.8, 1.8 plus 0.1, 1.9 plus 0.3, 2, 2.2, 2.2 plus 3.9, 2.2 plus 3.9, 6.1. That is 0.1 I is equal to minus 6.1. That is, I is equal to minus 6.1 divided by 0.1. That is if I multiply by 10 in numerator and denominator, then I get 61 by 1, minus 61 by 1 amperes. What does this minus sign indicate? What does it tell? It tells that our assumed direction is wrong. Magnitude of current is right, but it is coming negative. That is, actually current is going in this direction, or we can say towards right, minus 6.1 amperes towards right, or 6.1 amperes towards left. That's it. That is, we had got that. It means to say that current is going from here to here. That is, y is greater than x. Alright. So, what is my I? I will substitute over here. 0.02 into minus 61. That is, what is 122 into 1.22, it is minus 1.22 volts is my Vxy. That's it. This is my answer. So in this way we are going to apply our KVL, that is Kirchoffs Voltage Law, for loop sums.